All right, so this is lesson 1 on polynomial functions. Basically, it's a lot of vocabulary, so read through stuff. I'll skip through things quickly, but feel free to pause the video and stop and read through stuff and go from there. So basically, a polynomial is anything like this, where these are all real numbers. These are coefficients in front of the variable, and then the variable goes down with only whole numbers. You can't have any radicals or square roots or fractional exponents or anything like that, negative exponents. Those are things that make it a polynomial. So your exponents have to be whole numbers, 0 through whatever. So in general, the degree is however big the largest exponent is. This one is 4. Look, it's right there. The leading coefficient is the coefficient on the term with the highest degree. In this case, it's a 1. The constant term is the one that doesn't have any x's. Hey, it's 5. I know, rocket science. Anyway, here we just have to check and see if each thing is a polynomial or not. This thing is a polynomial there, is not here, because that would be like a root x. That's a radical function, not a polynomial. This one is not a polynomial because that makes it a rational function. Right? So that's not okay there. Should actually cross it out elsewhere other than right over top of the thing you're supposed to see. This one is 5. This one is not fine. And the reason is that this thing is 3/2 as an exponent. It's under the radical and it's an odd number exponent. So not a polynomial. This one is actually really tricky. The book, I think, says it is a polynomial because this would simplify to that. However, it's really this. That should be root 3. Absolute value x. So it doesn't behave the rest of the way a regular polynomial should. This one doesn't work either because you can't have a non-defined coefficient. Now, this is the biggest trick questions we can get. We can get it where it's not written in the standard form. Like, hey, that's the biggest thing. It's just not written up front. So degree is 3, leading coefficient -25, constant term -39. This one we can see is degree 2, because I have degree 1 thing multiplied by another degree 1 thing. Leading coefficient would just be that 10. If I were to expand it, I could expand the whole thing if I wanted to. I just don't need to, since I only care about really the first term and the last term. I don't have to bother with the rest of it. Although I could. I've just done that. Okay. This one, this is degree 2, and constant. So that's going to be a degree 4 thing. Leading coefficient would be this thing squared. So that's 9x squared times 5 would be 45 times this 2. So my leading coefficient should actually be 90. My constant term will be this -1 squared, which is going to be +1, times this 1 times that 2, so +2. And this thing, this is going to be a degree 2, and this is also a degree 2. So overall, it should stay a degree 2. You've got to be a little careful with that. I should probably expand and simplify this. I just don't want to. If you want, by all means do, or type it into Wolfram. But I'm going to be a little lazy. Anyway, this would be 18x squared, plus this 5 is 23x squared. This is going to be +1 times 2 plus 1. Constant is 3. I could do that graphically, too, if I really cared to. This thing has a degree of 0 because it would be like 7x to the 0th. And it's called a constant function because it's just y = 7. It's just a line like that. It just is constant. Okay, so hopefully that makes sense. I'm not going to write it down because, again, I'm lazy. This is all like handy vocabulary, but really not, I would argue, very important. It's trivia. That does not mean it won't show up on a test, however. So, sometimes it just is. Anyway, monomial means one term. Binomial, bi means two. So 2 terms. Try 3 terms. Hey, what a coincidence. Generally, we just say it's a, 4-term, 8-term polynomial. We don't say it's an octonomial or something like that. We also use degree, which is the highest power. So constant, linear, quadratic, cubic, or quartic. Quintic is 5. Hey, that's shown up on a test before. I don't even know what the other ones are. I would argue it's not important. Again, not everybody listens to me. Degree is just the highest exponent. Type, constant, linear, quadratic, cubic, quartic. You can see how much I think of that as being important. Integral polynomials means all of their coefficients are integers. Integer, 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 integer. That would be 1, just in case you're checking. Rational means it has something that isn't an integer, but is still fraction or repeating decimal. So that makes it rational. Again, not really all that important. It's still just a polynomial. Real polynomial means it has some things like e or pi or roots that are defined. They're still real, but they're not rational numbers. They go on forever. They're those irrational or transcendental numbers, if you will. Okay, so trinomial, quartic, and integral. 3 terms. 1, 2, 3. Plus, plus. Quartic means it has to be 4th degree. So this has to be like 2x to the 4th. Doesn't matter what this 2 is. Doesn't matter what other terms they are. As long as I have like an x and, I could even have like a 3. Or I could have had an x squared and an x. Doesn't really matter as long as there's 3 terms. Binomial, linear, real. So this one I have to have 2 terms. They both have to have different x's. Let's do x cubed and x. And then they have to be real, which means they can't be just rational. So I could have like pi x cubed plus root 2x. And I wouldn't even need to have both. Just one of those being irrational would be fine. Monomial, quadratic, and rational would be like 3/5 of x squared. But again, could be anything. So really, a rose by any other name would smell as sweet. A polynomial by any other name would factor just as nice. This is just sort of our function notation again, right? So that's the point 1 comma -9. All I have to do is plug the values in. So again, I'm just kind of rewriting it with that open brackets everywhere. And then in the open brackets, I'm going to parachute the values. So my x values are 1, and my y value is -9. And now I just solve. So -3, +8 is 5. Subtract 5 from both sides. -14 equals a. Ba-bam. And I can test that by typing it into my calculator, if I so care to do so. Same thing here, except now I've got 2 points. 2 comma -18 and -3 comma -13. And so now I just put those in both, and I'm going to have a system of equations. Again, really, like that's the hardest thing we got going on. So this is going to be 2 squared is 4 times negative 2 is 4 times negative 2 is negative 8. Add negative 8 to both sides, negative 10. So this is going to be negative 10 equals 2a plus b. And here I wrote those in wrong. It should really be negative 3's now. So 9 times negative 2 is negative 18. Bring that over here is going to be 5. So 5 equals negative 3a plus b. And then I would just solve the system. In this case, I'm just going to subtract down and make my b's go away. So 5a. And again, if you don't remember how to solve systems from back in Math 10C, focus on those or just come in and get some extra help. We can get you straightened out in no time. Once I've got my a is negative 3, then I would just need to pitch that value back into one of these two equations. I'll put it into this one and then solve it out. So 5 equals positive 9 plus b. b equals negative 4. Solved. Anywho. Hopefully I did that right. I'm not that convinced, but I don't really care. You can figure it out. You're smart. I love you all. Rock and roll.